Can you hear me? Hello, can you hear me? Hello. Hello, can you hear me? Are you hearing me? Hello? Yes. Then we start our class now. We are discussing something what? We are discussing moment of inertia. We are discussing moment of inertia now. And last class we learned two things. The definition of moment of inertia, or we introduced what is the moment, and then very important formula was the parallel axis formula, parallel axis theorem. That right? Parallel axis theorem is the parallel axis theorem is the moment of inertia with respect to any axis equal to moment of inertia with respect to centroidal axis plus AD square, right? If we calculate x from x, then it is dy square. If it is calculated y, then it is dx square. So that's we learned before. That's we learned yesterday. And then another one, the polar moment of inertia, z any axis through the z axis equal to z center plus AD square, same thing. But now we will now what we will do, we will learn something. Now radius of gyration is equal to kx is called radius of gyration equal to ix divided by area root over, or ky equal to iy divided by a root over a. So this is the radius of gyration formula. And what is radius gyration? Is a planar area has a unique length and it quantity used in the design of the column in the structure member. But right now you just learn the radius of gyration, the definition and the formula only. Maybe we will not doing this in detail. Okay. Next is now we learned what we learned already. We learned that moment of inertia equal to yx to the power x dA, and iy equal to moment of inertia integration of x squared dA, right? That's what we learned previously. Now what we learn now, we want to learn that moment of inertia with respect to rectangular area, with respect to moment of inertia with respect to the rectangular. Now, there is a specific formula for each shape. Like for triangle, there is a formula. For rectangle, there is a formula. For circle, there is a formula. So here I will just show you the one example that here only one example that how this formula derived, right? Suppose here is the rectangle, and rectangle is breadth or width, whatever you say, is b, and height is h. And you all know that the center will be in the just middle b by 2, and from the h by 2 will be the center. And this is the x bar is the centroidal axis, and y bar is the centroidal axis. And we select. Now we want to calculate we want to find the moment of inertia through the center. through the center with respect to x-axis, with respect to x, or what, with respect to x or x prime axis, whatever you say. Now, if this is the center, this is the central axis. Now we want to calculate, we want to find what is moment of inertia for this rectangle, and for that reason we know the formula dy square a. So we select very small dy thickness, right? Thickness is dy, and thickness and width is b. Width is b. So if now we integrate for a, so y square is in how much? Y square meaning is from x to the center of the from s to the center of the strip. So we take very small center split. Here is y prime. Y prime is here. Here y prime is our distance. So y prime square is the distance, and the area is dA. What is the area? Area is very small, b into dA. B into dA, because breadth is the b into dA. So we can write b into d, not dA, dy, very small, right? dy prime, b into dy prime. B into dy prime is the area. So for area equal to, so minus half, and it is plus half, right? Minus half of the h, because we are doing from x-axis. So distance is from here is minus half, and from here up to is plus half. So our integration limit is minus half to plus half h, right? So then you just do the integration, and after doing the integration, you will find the result is bh cube divided by 12. Bh cube divided by 12. If you do this, so b into, it is like this, b into, so y bd into y, this is y cube divided by cube, and here is the plus h by 2 and minus h by 2. And if you do calculation, you will find the ix equal to this is the formula ix. So that meaning is if a rectangle is given to you, like this is the rectangle is given to you, and the rectangle width is b. Are you there? Are you hearing me? Hello? H by 2, sorry, no, this is the h, if it is the h, height is h, and which is with, then ix equal to this formula, ix equal to then ix bar. What is the x bar? Meaning is this is the center. If x go through the center, then ix equal to bh cube divided by 12. This is the formula. Now remember, this is bh cube 12, and y bar, this is y bar. Y also going through the center, right? Then y bar equal to, now 12 is there. Now only change will be, what will be changed? Look, the difference here, h cube is to the cube on h cube. So here will only change b cube. That's the change. Okay, only this is the changing. Okay. So b cube. So for now, you need to remember this some formula. For remembering this formula, for x, the parallel is b. Parallel has always 1. You remember like this. For y, parallel is h. So h always 1, and another one is 3. B cube by 3. So this is the formula for the what? This is the formula for the moment of inertia of a rectangle shape through the axis, right? Now I showed you I have given you the one page of the formula. I have shown you on another day where it is. If it is not there, it should be here. We have to find it again. Anyway, you go to your page and go to the course content. In course content, I have given you the one page. This Geometric properties and line of the area. Geometric properties, line of the area. Right? Here, geometric properties of line of the area. Here I show you before. You see there, you see there, you see here rectangle, right? Rectangle. I just shown you before, and here also rectangle is what? Rectangle is, you find Ix is equal to Vh cube by 12 and Ix is equal to Hb cube by 12, right? For rectangle. So the formula is similarly for triangle, the similar process of integration we follow, and we'll find for triangle BH cube by 36. B is the base and H is the height, and then BH cube by 36. For circle, Ix is equal to 4r to the power 4 and Ix Iy equal to same 1 pi r to the power by 4. If it is the semicircle, then the formula is this: Ix 1 by 8 r to the power 4, Iy 1 by 8 r to the power 4. If it is the quarter circle, then pi r to the power 16, pi r to the power 16. If it is the circular sector area, then this is the formula, right? Like pi r to the power 4 into sine minus half sine 2 theta. So these are the form shape already, they are already given there. So this side is telling you the moment of inertia, area moment of inertia, and this side is telling is the centroid location, right? Okay, so so here what I have shown only one proof how to find the moment of inertia for rectangle. Similarly we can find moment of inertia of triangle, and the result will be, if it is the B, if it is the B and if it is the H, it will be Ix, center will be, center will be here, and if then Ix equal to Ix by equal to for triangle BD cube by BH cube by 36, BH cube by 36, and this is BH cube by 36, and this is written there, you see, BH cube by 36. All right, now so like this, okay, and they have proved this one. Now go back to the again rectangle, go back to the, now we are doing the again rectangle, go back to the, we already learned what we already learned. We already learned, then tell me what you learned already so far. What we learned already, if this is a rectangle we have, and rectangle width is B, and height is H, and center is somewhere here, and centroidal axis is X prime, and this is Y prime, and central is like this. Then in that case, Ix bar equal to B H cube by 30, B H cube by 12, and Iy bar equal to B cube H divided by 12. That's the we already learned. Now, last class we learned one formula. What is the formula? With respect to any axis, suppose xx prime, with respect to any axis, the moment of inertia is Ix bar through the center plus AD square. AD here will be y, right? D square. This is what? This is the called parallel axis formula. Suppose this is our axis. Its name x double prime. We give some name x axis with double prime. Now with respect to this axis, this is the formula. This is the formula. With respect to centroidal axis, our formula is this. Now our question is, with respect to this axis, what is the formula then? What will be the formula x double prime? If it is x double prime, then what will be our formula? What is the formula? We don't know, but we can calculate from this formula. As we learned already, it is the, if it is the, so from centroidal axis, this is the formula. And in any other axis with distance, with some distance, suppose this distance is I give name dy, from here to, from the new axis to the centroidal axis dy. Then what is the moment of inertia? So moment of inertia, as per the formula here, we write down the Ix bar plus AD square. So what is the area? area is equal to B into H, right? B into H. B, here is the B and here is the H. B into dy square. So this is the distance is dy square. So we write down dy square. So if we write down dy square, then what we already learned, so for ix bar equal to this, right? So ix bar equal to this, then we can write bh cube divided by 12 plus 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 bh plus and dy equal to how much here? Dy equal to h by 2. Here dy equal to, we know h by 2. So we write down here. So here we write down dy square equal to here h by 2. Dy equal to h by 2 square, right? Because dy equal to h by 2. Dy. So dy equal to h by 2. So b into h into this h cube is cube and this 2, right? So b is there, and h is cube 12. So finally what we have, if we do the final calculation, you will find bh cube by, this is bh cube by 3. So and this is actually what? This is actually what? This is actually base. This is actually what? This is actually baseline, right? Base. So with respect to base, our is base of what? Base of rectangle. So with respect to base, our moment of inertia is bh cube by 3. Similarly, if we say if we take the another side base, this is the base, so another side of the moment, if you select Iyy, in that case Iyy prime, I double prime will be, this is similar calculation will be b, just b cube by h12. This is the changing, sorry, 3. will be formula will be cube by 3. So what we learned so far? So we learned the moment of inertia with respect to, for rectangle, with respect to the centroidal axis is this, and with respect to base is bh cube by 3, and with respect to the another side of base, whatever you say, it is I equal to b cube h by 3, right? These two things we learned. So do you have any questions so far? Please tell me. Please tell me if you have any question. If you don't have the question, so far what I have discussed is proof like this way. They also write down like this, so you can see the slide also. All right, and this is, I just skip it now for this time. This is the similar formula for in z-axis, x-axis, y-axis. If you do the z-axis, the polar moment of inertia is like this. Anyway, we skip it this right now. Now moment of inertia, now we now start learning the moment of inertia with respect to composite area. Composite area means, like I told you before, like this different combination of different shape. So now we'll do the composite area. This is the composite area, right? This is the, as example, this is the area. This looks like a T shape. So what is the moment of inertia of this? So I will do now one. So now we will do one example of the moment of inertia. Compute moment of inertia with around the x-axis. So they ask around x-axis. Where is the x-axis? X-axis is here. Remember, where is this x-axis? X-axis is actually in the base. It is actually base, right? Now Are you hearing me? Hello? Are you there? Yes, if you there, then tell me the formula. Tell me the formula, please. We just learned now. They're asking about the IX. What is the IX? What is the IX? Now here we have two shape, composite area, right? Here we have two shape. One is the rectangle. One is the rectangle we have here, rectangle, and another one is what? Another one is circle. What is the IX? Now tell me, for IX, what is the formula? Tell me quickly. We just learned it 1 minute before. Abdul Malik, Khalid, tell me, what will be the IX formula? Can anyone tell me or cannot tell me? BH cube at 12. This is the center. Kamal Ashraf, you said something correct, but it is with respect to center. But I am asking you with respect to here. Where? If it is our axis goes through the bottom baseline, our axis, now they are asking the question X, and I see X is here. Then what is formula? We just line 1 minute before, BH cube 3. Thank you. Yes, correct. Yes, now it's correct. Yes, now it is correct. So for rectangle, we have two shape here. We have two shape. One is the rectangle, one is the circle. So IX equal to, I write down IX equal to, for rectangle, that means all together is BH cube. You write down that BH cube divided by 3. What is the B here? What is the B? B equal to 100. B equal to 100 into H. H is, this is a H. This is the H. 75 plus 75 equal to 150. So 150 cube. 150 cube divided by 3. Right? So this is our rectangle. But the problem is, we have to, this is the hollow area, this is the not there. So what we have to do, we have to deduct the area. We have to deduct. So minus, deduct means minus for circle. Now my question is, what is my question? This for the circle. Circle center is going there, center is there, center. This is the center. And with respect to circle, what we learn from here, the moment IX. What is with respect to center, right? With respect to center, I, so I bar, center means I bar, and it is the I bar X. I bar meaning, again, don't be confused. What is writing there? What am I writing there? With respect to center. What is the, for moment? What is, can you tell me? What is written there with respect to center? Can you see this one? What is this? 4R by 4, right? Pi 4R by 4, IX. Actually, because it is a circle, this IX and IY is same anyway. So written is, so IX actually for center, if it is go through the center, then our result is pi R to the power 4 by 4, right? Pi R to the 4 by 4. With respect to here, with respect to this line is I equal to for circle, I can write down circle equal to pi R to the power. How much the R is there? How much is R there? Tell me. I can see R is 25. So 25 millimeter to the power 4 divided by 4. But so I write down pi R to the power 25 to the power 4 divided by 4. But problem is, we are doing the calculation from this axis, not from here. So we have to transfer, we have to go directly from here to there. And for going there, we learn we learn the parallel axis formula. And parallel axis formula is I bar center to the power AD square, right? So I bar is, we already write down here. What is the I bar? The plus AD square. So what is the area for the circle? Tell me please. What is the area? Pi R square, right? Formula is pi R square. Let me the more space to write down. Pi R square. Yes, you are correct. So minus here, then here, for the pi r to the power 25 to the power 4 divided by 4. This is the center, plus area. Area is, you told me, pi r square, r equal to how much here? 25, r equal to 20 square, into d square. What is the d? Now tell me d. D is here 75. D is 75 square, right? And then finish, right? So now do the calculation and tell me. So this is 100 into 100 into 150 to the power 3 by 3 minus pi to the power 4, and then this is. Do the calculation, and then always the result will be millimeter to the power 4, right? For moment of inertia, unit is always unit to the power 4. Always remember. Okay. Now you tell me do the calculation and tell me the result, please. 1 minute time. Can you repeat the circle? Yes. I can repeat the circle, but you do the calculation, please, and tell me the result. Class, I'm in class. Come later. For the circle, circle at the center, right? Circle as the for center we already learned. For center, moment of inertia is pi r to the power 4. Pi r to the power r is 25. Pi r to the power 4. Okay. But this is with respect to this axis. But we are calculating for this axis. For this axis, we have to add this one, AD square plus A. So A equal to pi d pi r, right? R is 25 square into pi r square area into d square. So d is how much? D is the distance. What is the distance? Distance between two axes. This is the CG or centroidal axis. Centroidal axis. Between and the axis, it is our axis, right? What axis we want? So this distance is here 75. So 75 square. Now we have to deduct. So this one minus this one, okay, minus this one, and do the calculation and tell me, please. It has been long time, so you didn't tell me the result. Please tell me the result, please. Well, if you cannot tell me the results, result is here, right? Result is here, so you double check with the result, right? And tell me the next class if you have any problem. But I want to continue further, so that's why I am going for. Assalamu alaikum, I'm in class. Class niche. Ji. All right. Now I want to start another problem, right? I want to start another problem. But do you have any problem? Any question here? Tell me. Tell me, please. Response your name count, please. Muhammad Hafiz. Muhammad Hafiz is there? Absent. Muhammad Abdul Aziz Mazen. Abdul Aziz Mazen. Absent. Kumar Hussain. Kumar Hassan there? Absent. Muhammad Abdul Aziz. Abdul Aziz Hassan. Absent. Muhammad Ahmad bin Abdul Rahman. Okay, there. Muhammad Yusuf. Muhammad Sami. Muhammad Sami. Muhammad Sami. Muhammad Sulaiman. Muhammad Sami bin Sulaiman. There. Ahmad Tahir. Ahmad Tahir is there. Abdullah Muhammad. Abdullah Muhammad Abdullah. Absent. Abdul Malik Khalid. Umar Abdul Aziz. Umar Abdul Aziz. Absent. Ali Muhammad Munaim. Isa Abdullah. Isa. Yahya Abdullah. Yahya Abdullah. Absent. Muhammad Walid. Talal Jamal. Talal Jamal. Absent. Saud Sama. So Yahya is there. Saud Sama is there. Yes. Hussain Ali ibn Hussain. Faris Fahad. Abdulillah Fahad. Ali Jawad bin Haji. Talal is there, right? Okay. Hussain Abdullah bin Bakir is there. Ahmad Imad ibn Ali. Okay. Abdullah Saadun. Abdullah Saadun. Ahmad Dia. Muhammad Salah. Hussain Jawad is there. Faris Mohadil, Abdullah Saleh, Saad Muhammad. Saad Muhammad is there. Okay. Abdul Munaim. Abdul Munaim. Abdullah Saad. Umar Wahid. Umar Wahid. Muhammad Shabir. Shamsan Saleh. Shamsan Saleh. Umar Ahmad bin Umar. Jamal Raed. Kamal Ashraf. Umar Usama. Umar Usama. Abdullah Nasir. Musa Muhammad Isa. Abdullah Said is there, right? Okay. Now I double check. Muhammad Habis is there. Muhammad Habis. Kumail Hussain. Kumail Hussain. Muhammad Aziz. Muhammad Abdul Aziz. Here I had in the pronoun. Talal Jamal is given, right? Abdullah Muhammad. Abdullah Muhammad. Umar Abdul Aziz. Umar Abdul Aziz. Not available. Shamsan Saleh. Not available. So I confirm. Okay. Now we will do now another. I don't know. I confirm already. Murasama. I don't know. You are absent or present. I don't know. I already confirmed there. So here now we will do one more example now, and that is in chapter 1033. Okay, problem number 10, chapter 1033 in the from exercise. This is from exercise. Okay, this is from exercise. Now what we will do here, ix, find the ix or iy. Okay, find ix. Now this time we calculate iy first. Iy, we want to calculate iy with respect to y. Okay, with respect to y we learn, and then why we selected this one, because there is you already learned this, and now we will do the triangle. We'll do the triangle. But in exercise and the practice problem I have given, there is lots of area other, like you have their semicircle, you have their quarter circle, different shape there. So you do the practice exercise there. Now here I will show you the some student is lifting out now, so I will make absent in next class. Okay. Abdullah Saad, right? Saad Muhammad. Abdullah Saad Muhammad. So I can see the screen who is leaving before the class. So I keep in the note, and I will make you absent in the next class. Okay. So Abdullah Saad. Muhammad Habis, you already I put absent because I have asked you 5 or 6 times. I didn't get your response. So Abdullah Saad. Okay. Now we calculate the ix and ix. Now iy. Now we'll calculate the iy, right? Iy. So iy, calculate iy. We have a 3 shape. So we think we selected this is 1. We have 1. We have 2, and we have 3. Now first we triangle, right? For triangle, we learned for triangle, I show you, for triangle, I showed you their formula is, if it is the axis, center, here center is here, right? Ix is here. So if through this center, there is 2, right? Now, because we are calculating Iy, so this is the, we will consider this one, right? We will consider this one. And Ix, Iy, we learned for BH cubed by 36. We learned this one. For here, we learned this one, right? The for triangle. So for triangle, if it is this one, so formula is 36. We write down. So BH cube. Which one is B? Which one is B here? B is this one. As I told you, the parallel one, parallel to the axis, we consider as a B, and B is here 200 into H. H is one parallel perpendicular to the axis. So axis is this one, right? We select this is the axis. Centroidal axis is 300 into 300 BH cube, right? BH cube by 36. But we are calculating from the this axis. So this one is from the center. This one, whatever I wrote, it is from the center. Center of what? From the centroidal axis. From the centroidal axis of triangle. This one. But we are calculating from here, right? So our axis, we have to transfer in this axis and this, within this distance, and this distance is 300. So we have to write there AD square. So as we learned there, Ix bar plus AD square. So area is how much? Area is half. Base is 300 into dA. Is height is how much? 200 into d square, and d square is how much? D square is 300. So 300 square. 300 square. Not 300. Sorry, not 300 square. I wrote down. This is wrong. Area is, so here, from here to here, center is how much? What is the distance? The distance is, now one thing I did wrong, and I tell you. So center is here, right? The center is from the base. We already learned from in the chapter 7 that the center of triangle is 1/3 of the height, right? Or 1/3 of the base, 1/3. So here 1/3 is from this distance. This distance is 1/3 of 300, right? 1/3 of 300, and from here to here is 2/3 of 300. 2/3. So 2/3 of 300 equal to this distance is actually 200. This is 200, right? So here will be 200, not 300. Here will be this will be actually 200 distance. Okay, so we calculate for the triangle. Now section 2 is, we have rectangle. Again, for rectangle is, we learn already, B for rectangle is with center, with respect to this is the center, right? With respect to center, BH cube by 12. So B equal to here, for B equal to here, we have B is this one, because we are doing with respect to this axis. So B is here 100, B is 200. So 200, and H cube is 75 cube. Now remember, as I told you, the formula is B and H. Which one B and which one H? You have to understand from where. If it is the parallel to the axis, then it is B, and if it is perpendicular to the axis, then that is H, right? That is H. So B is here 200 and H is 75 by 12. Because now our center is there, right? We are the BDH cube from this formula, but we are calculating from there. So we have to transfer from there to here, and this distance, right? And this distance is how much? 300 plus half of the 300. No, sorry, this is 75 is not the, look, I clean it. So we are doing the mistake because it is become clumsy. So I clean it and then do it again. Otherwise we will do wrong. Everything will do wrong. Okay. Everything will do wrong. So here it is 200. It was 200 square plus. So here I did it wrong. I do it again, right? Again. For we are calculating IY. We are calculating IY. So y is this axis, right? To calculate this axis, the section two, we have to calculate the center of this axis. And here is for the center. We already know this is the BH cube by 12. So B is this distance is B. This is 200, and H cube is from here to here. Actually, here to here is 300. 150, 150 is 300 actually. 300, right? 300 cube by 12 plus AD square. Why AD square? As I told you, if it is from the center to, we have to go somewhere else, another axis. So from here to here, so we have to transfer there, and then distance is 150 and 350. So 450. This distance is millimeter, right? So we have to write the AD square. So what is the area? Area is 300 into, this is the 300 from 300 into 200 area into D square. D square. What is the distance? Distance is 450. 450. Done. Right. Now now we have section 3, and section 3 is a circle. Section 3 is what? Section 3 is a circle, and the circle radius is 75. Circle radius is 75, and this we have to deduct. So we deduct minus. So as we did the circle in just previous example, simple, like pi r to the power 4. So pi r to the power 4. What is the r? R is 75. R is 75. Here r is 75. Remember, there is a two different things. Sometimes r and d. In exam, maybe d is given, then you have to convert to the r. So pi r to the power 4 divided by 4, right? Plus AD square. Again, we have to go, this is r to the power 4. This formula r to the power 4 is r to the 4 divided by the 4. It is what formula? It is formula through the center. But Abdul Ilah, you are leaving now. Okay, next class you will be absent. Okay. So prior to the 4 area. So what is the area? Area is the pi r square. 75 square into d distance. Distance is from, we are doing from this center to here, right? Distance is, again, this center is 450, and you do the calculation. If you do the calculation, and this is the result, and result always to the unit to the power 4. So it is millimeter to the power 4, right? If it is meter given in meter, then it will be meter to the power 4. But here is given meter. And do the calculation, please. You have 2 minutes time. Do the calculation and tell me the result. Tell me the result. Okay. Next class you will have the quiz, inshallah, and on chapter centroid chapter, right? And you do the calculation. Tell me the result, please. Yes, what is the chapter 9, or I don't know. What is the chapter 9, was center or something? Chapter 9, yes, chapter 9. Chapter 9 is the center, but you tell me please the result now. One point three 10 to the power 9, right? Yes, correct. I think answer is correct. Thank you for the calculation. 10 to the power what? 10 to the power 3. Write down more clearly. 10.33 10 to the power 9. All right. So done, right? So similarly, I give you the homework. Homework is Ix. You calculate the Ix similarly with respect to this axis, and tell me the result. What is the y-axis? Okay, in midway to the 4 y-axis. So we did the y-axis. Now you will do the x-axis. You have to do the from x-axis. How we'll do our triangle? For triangle, our center will be there. So you do the from there, and actually it is more easier, right? It is more easier. And for triangle, for the rectangle and the circle, it is almost exactly similar to this problem, right? We have done here. So this is similar to that problem, just we add the triangle here, right? So you do this calculation, and it is very, if you understand this, so you just add the triangle result, and you should get this result Ix. So next class, I have a bad internet, doctor. I tried 3 times to log in again. Thank you very much. Thank you. So you will be present, no problem, don't worry, Abdullah. So Ix, right? You calculate the Ix. So your homework is calculate the Ix and tell me next class. Now, you have any question? Otherwise, we can finish here, right? You can leave now because time is finished.